Good morning to one and all. Welcome back our favorite video channel SGVS. This is B Ramesh Kumar, JL in Mathematics. In previous videos we discussed system of linear equations direct methods. Now this time we discuss the concept consistency and inconsistency to the given linear system. First of all, let us consider one system which is n variables, m equations. Now the system is, let a11 x1 plus a12 x2 plus a13 x3 plus and so on plus a1n xn. This equals to some b1. a21 x1 plus a22 x2 plus a23 x3 plus and so on plus a2n xn. This is some b2. a31 x1 plus a32 x2 plus a33 x3 plus and so on plus a3n xn. This equals to some b3. Similarly and so on. Here we take m equations. That is a m1 x1 plus a m2 x2 plus a m3 x3 plus and so on plus a mn xn, that equals to some bm. Now this is one linear system. Here the linear system means the power of each variable equals to 1. Now that system is called linear system. Here we take m equations with n variables. This is called one linear system. First we write this system in matrix form. Here we take the coefficients of the variables a11, a12, a13 up to and so on a1n. Similarly the second one a21, a22, a23 up to and so on a2n and so on. am1, am2, am3 and so on amn. So this is the coefficient matrix of given system. Similarly we write the variables in column wise x1, x2 up to xn. Now we write in RHS side the column wise the constants b1, b2 and so on bn, bm. So here this is called coefficient matrix, this is called variable matrix or unknown matrix, this is called constant matrix. Let us assume that the coefficient matrix is denoted by A, this is some x, this is some b. Now here the matrix form is Ax equals to b. Now Ax, the matrix form is Ax equals to b. So here in this matrix form Ax equals to b, this can be classified by two ways. Here we observe that the constant matrix B is equals to 0 matrix. Here in this system the right side values, the constants are all zeros, then that system is called homogeneous linear system. Here B equals to null matrix or 0 matrix. Then the system is Ax equals to O, which is homogeneous linear system. Here in homogeneous linear system we take x1, x2, x3 and so on xn equals to zeros. Then substitute these values zeros in this equation. Then it will satisfy the right side value which is also 0. So here compulsory the homogeneous system has one solution. That solution is zero solution. So here this system is called consistency system. Here any system has one solution, at least one solution. That system is called consistency system. Here this is always has one solution, that is zero solution. Here x1 equals to x2 equals to and so on, xn equals to zeros. Therefore, homogeneous system is always consistency system. Similarly, in this constant matrix, at least one value is non-zero. Here b1, b2, b3 up to bm, at least one value is non-zero. That type of system is called non-homogeneous linear system. Here, if at least one bi, I equals to 1 to m, is not equals to 0, then that system is called non-homogeneous system. Therefore, the system is non-homogeneous system. Here we observe that zero solution is not satisfied all equations. Therefore, here the system has either solution or does not exist any solution. So here the non-homogeneous system is consistency or inconsistency. Now we go to some flowchart to the system of linear equations. Now we discuss flowchart of consistency and inconsistency system to the given linear system. So system of given system is system of linear equations. Here the matrix form of this system is Ax equals to B. Next, in this matrix form, the constant matrix B is always equals to null matrix or zero matrix. That means each and every element of constant matrix equals to 0, then that system is called homogeneous linear system. So this is homogeneous linear system. Here Ax equals to B is always equals to null matrix. Now here we observe that the zero solution is satisfies every equation of the given system. Therefore, it has one solution, that is zero solution. So compulsory one solution exists to the system, then the type of system is called consistency system. Here zero solution exists for this system. Therefore, homogeneous system is always consistency system. Here we observe that homogeneous system is always consistency system. Here in this consistency system, it has one solution or more than one solutions. So only one solution. Now that solution is zero solution. Which solution is called trivial solution? So zero solution is always trivial solution. Based on rank of the given system, rank of A equals to number of variables or number of unknowns. which is denoted by some n, which implies rank of A equals to some R equals to n based upon rank. And also another way is find determinant of quotient matrix. Find determinant of quotient matrix that is not equals to 0. So here det A is not equals to 0, which implies that A is not equals to 0. So this trivial solution is one and only one solution, therefore that is unique solution. So here this system is unique solution. This system has unique solution. So this is rank of A equals to n, that means R equals to n. Another way is determinant of quotient matrix is not equal to 0. Similarly, this consistency system has more than one solutions. That means that type of solutions is always non-zero solutions or non-trivial solution. So here exists non-trivial solution. It exists if here rank of A is less than number of variables. So here which implies R is less than n. Based upon rank of quotient matrix is always less than number of unknowns. Here non-trivial solution exists. Non-trivial means zero solution includes in any other one non-zero solution. So based on determinant, here det A equals to 0. Det A equals to 0, which implies that A equals to 0. Based upon determinant, this is based upon rank. Now here non-trivial solutions means more than one. Therefore, these are infinitely many solutions. So this system has infinitely many solutions. So this is the homogeneous system and the solutions of this system. The next one is here Ax equals to B. In this the constant matrix is not equals to null matrix or zero matrix. That means at least one element of constant matrix is non-zero. That type of system is called non-homogeneous linear system. So this is non-homogeneous system. Here the matrix form is Ax equals to B, which is not equals to O, not equals to null matrix. So here we observe, if the system has either a solution or not any solution, has not any solution. For suppose this system has at least one solution, that type of system is called consistency system. Otherwise it is called inconsistency system. Now first here we take inconsistency system. Here there is no solution for the given system. So based on rank, here rank of augmented matrix is not equals to rank of A. So here rank of augmented matrix is not equals to rank of A, then that system has no solution and we say that the system is called inconsistency system. So here rank of augmented matrix means first we take quotient matrix, besides we write constant matrix. The total matrix is called rank of total matrix is called augmented matrix. First we find rank using transformations. At the same time in that augmented matrix we get rank of quotient matrix also. So here we observe rank of AB and rank of A, these are equal. The system is consistency, not equal inconsistency. So here not equals to, then therefore the system is called inconsistency system based on rank. Another way is based on determinant. Here we take one quotient matrix to the given system to find determinant of the quotient matrix. That determinant equals to 0. That determinant equals to 0. So it means that A equal to 0. And another condition also satisfied. That is at least one dx or dy or dz is non-zero. Here at least one dx, dy, dz. In this one, first we find determinant of quotient matrix. Generally that is denoted by D. D equal to det A. So det A is 0 and here dx means the first column of the quotient matrix can be replaced by constant matrix. Then find dx, that is dx. First column is B and remaining two columns are A. Find determinant of this matrix, that is dx. Similarly, dy, find dy. In the second column is B, first one and second one is A. Find determinant. Similarly, we find dz. Here, first column, second column is A, third column is B. Find determinant. Now, at least one of the determinant of these three is non-zero and determinant A equals to 0, D equals 0. Therefore, the system is inconsistency system. So, here we write at least one dx, dy, dz is non-zero. So, therefore, this is inconsistency system and it has no solution. So, no solution. So, this is the procedure of inconsistency system. Next, suppose the system has exactly one solution. That system is called consistency system. So, the condition is consistency system. Consistent system. Here also consistent. So, consistent system. Here, either the system has one solution or more than one solutions. For suppose the system has one solution. If the augmented matrix rank of augmented matrix equals to rank of A. Rank of augmented matrix equals to rank of A. That equals to number of variables. That equals to number of variables or number of unknowns. Therefore, the system is called consistency and the system has exactly one solution, that is unique solution based upon rank. So, consistent system means based on rank of AB equals to rank of A equals to n, number of unknowns. Based on determinant, first of all, we find determinant of the quotient matrix, that is not equal to 0. That is not equal to 0. So here the first condition is based on determinant D equals to det A, which is not equal to 0. Similarly, find dx, dy, dz using the relation, that is x by dx equals to y by dy equals to z by dz equals to 1 by d. Using this relation, substitute the values dx, dy, dz and d in this relation, then find the values of x, y, z. That is the one and only one solution. That solution is unique solution. Next one. Suppose the system has more than one solutions. Here this condition exists if rank of augmented matrix equals to rank of A and less than number of unknowns. Here rank is less than number of unknowns. So rank of AB equals to rank of A, which is less than n number of unknowns based on rank. Therefore, the system has more than one solutions, and also the system is consistent system. Based on determinant, here first of all we find determinant, that is 0. Here in this condition, determinant of quotient matrix is 0, and at the same time, the second condition is here find dx, dy, dz. These are all equals to zeros. Here the values of dx, dy, dz are all equals to zeros. That is the second condition. So dx equals to, dy equals to, dz equals to 0, and determinant of coefficient matrix d is also 0. So these two conditions exist for this system. Then the system has infinitely many solutions or more than one solutions, and the system is consistent system. So the number of solutions are infinitely many. So this is the procedure for non-homogeneous system, which is consistency. And briefly, once again I explain total flowchart. So given that the system of linear equations, the matrix form is Ax equals to B. Here the constant matrix B is always equals to 0 matrix. The system is homogeneous system. In this homogeneous system, 0 solution is satisfied all equations of the given system. Therefore, the system is system has one solution. Now we say that the system is called consistency system. So here in this consistent system, it has one solution or one or more solutions. For example, it has one solution, that is 0 solution. Which solution is called trivial solution. Now this trivial solution exists if based on rank, find rank of coefficient matrix. Rank of A equals to number of unknowns, that means R equals to n. Then the system has one solution, that is consistency system. Similarly, based on determinant of quotient matrix is not equal to 0. Here also the system has consistent system, and it has one and only one solution, that is trivial solution. So which is unique solution. Similarly, in this homogeneous system, it has more than one solutions. That means including 0 solutions other than non-zero solutions. That type of non-zero solution is called non-trivial solution. Based upon rank, here also rank of A is less than number of unknowns, that is R is less than n. Now the system has more than one solutions or non-zero solutions or non-trivial solutions. And another way is based upon determinant. First of all, find determinant of coefficient matrix. Now which is equals to 0. Then the system has more than one solutions. These are non-trivial solutions. Therefore, here the number of solutions are infinitely many solutions. This is the homogeneous system. Similarly, in non-homogeneous system, first of all, the given system Ax equals to B. B is non-zero matrix. That means at least one element of constant matrix is non-zero. The type of system is called non-homogeneous. Now it has either a solution or does not exist any solution. For example, there is no solution. That type of system is called inconsistent system. So in this inconsistent system, based upon rank, first of all find rank of augmented matrix. We find rank of augmented matrix. Now the rank of augmented matrix is not equal to rank of coefficient matrix using row transformations. Using row transformations, find rank of augmented matrix. We observe that rank is not equal to rank of coefficient matrix. That system is called inconsistent system. And based upon determinant, we find that A. So determinant of coefficient matrix equals to 0, and also find dx, dy, dz. Dx, dy, dz already discussed. Now in this, at least one dx, dy, dz from these three, at least one determinant is not equal to 0, also the system is inconsistent system. Therefore, the number of solutions is 0. That means no solution. Similarly, the non-homogeneous system, at least one solution, has at least one solution. That system is called consistent system. If the system has one and only one solution, now here exists if rank of augmented matrix equals to rank of A, and also which is equals to number of unknowns, then the system is called consistent system. Here, based upon determinants, first of all we find determinant of the quotient matrix, then which is not equal to 0, and using the relation x by dx equals to y by dy equals to z by dz equals to 1 by d, and find the values of x, y, z, which is one and only one solution. Now that solution is called unique solution. Here number of solutions equals to 1. Similarly, suppose the system is inconsistent and it has more than one solutions. If the rank of augmented matrix equals to rank of A, which is less than number of unknowns using transformations, and here this condition exists, then the system is consistent system. And based upon determinants, first of all we find determinant of quotient matrix, now which is equal to 0, and also the another condition is to find dx dy dz, all dx dy dz are equals to 0. Both these two conditions happen for this system, then that system is consistent system and it has infinitely many solutions. Therefore, here the number of solutions are infinite solutions. So this is the procedure for system of linear equations, which is the flow chart of this consistent and inconsistent systems. Now, preparing this concept to the given systems to find solutions or test for consistency to the given any system also. This is the process. So, thank you.